Hello folks, well I find myself with 15 minutes, so I'll make a start on this radio. Doesn't get much better than this, does it? A boxed Harrier CBX for the gentleman from the trucking and farming business in Leicestershire. So, I think we've got a scruffy one to service and sell, but this is going to be immaculate. Right, trucking and farming. Oh, I better get the duster out. So, got a bracket in there. He's got the factory original mic, which we'll do with the on-the-air test. Good quality replacement power lead. So we'll put that on one side. And we'll get the duster out. Well, I don't know when I last saw. I wish that decal company did a Harrier CBX, because it would. I just keep looking at. Let's just try and get in the glare of the fluorescent lights above me. Wow. God. You know what? It's still got. It's still got. It seems to have still got that one on. Anyway, we don't play. I don't play that game. Right, we need to find, rather than use his power lead, should be a bit of one on here. Well, there should. Otherwise we'll simply get a new one out of stock. Right. Let's get some stuff plugged in. We'll plug our speaker on the wall into the public address socket for now. I've only just put the test equipment on, so we won't do any frequency things for a bit. Right, we're going to start this on 9 volts, and we're current limited to 300 milliamps, just as a precaution. Right, we'll pop it on to 12. And we will plug a mic in. Our standard replacement mic. And check if it works in PA. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. It does. So here we go. That works. And that works. So go to CB. And we'll swap the, we'll take that out and we'll plug in the test equipment, especially if I can find it. It's going to need an earth, isn't it? So we're going to have to open it up to do receive. Because we've got the earth snipped off these. Tell you what, we might be able to put a crocodile clip on the earth and do an outer plug like that. Right, we'll start with transmit. We're going to go to 13.8 volts. There we go. And I'll put you on picture in picture. And we press transmit. We're on the 3 watt scale. And it's just doing 3 watts. If I go to the 30 watt scale, it's actually saying like 2.95, something like that. So, channel 20, 3 watts. Channel 40, 2.9 watts. I put it in the wrong box. Channel 1, 3 is 2.9 as well. Normally you find it's higher on channel 1 than it is on 40. It's quite well balanced. It's very well balanced. Right, let's go over to, going back to channel 20, it's 948 milliamps, which is a lot for that output on this chassis. Let's go over to low power. I've actually got a light coming on telling me I've got excessive rubbish coming in. 79. We'll put down the frequency 2779087, and I've got 140 milliwatts. So I've got a light here on the test set. I'll just see if I can. We'll go to camera 6. I might be able to just move that across. And what this is for, you see where we're connected. We've got the 3 watt 30 watt switch, and then we've got the end connector which goes to the aerial socket on the back of the radio. So when I key it up, we're on low power still, you can see nothing happens. When I put the radio on high power, it's putting up a warning. Now that is a warning for it's a twofold warning. If we went over 30 watts, remember this is a business radio test set, so business radios in this country are often 25 watts, but they don't go higher than that. But in tuning them up, you will go over 30. We'll go over 25 watts. And the other thing this does is it will put that light up if the spurious emissions are excessive. It's kind of a bit of a warning to tell you to put the radio on a spectrum analyzer. So we have the warning. Right, back to have a look at deviation. Wow, it's 1.5 on this test set, but that doesn't mean much. 1.5. When we key it up, what we got says 3.8. It's probably about right for itself. Let's go to receive. We'll put this frequency into the test set. Let's go over to the frequency counter. Oh, mice have moved the camera to a sensible position, I see. 2779. 125. I'll switch the other test gear on. 2779. One. Come on. It's quite cold today. One. I'll drop it a bit just to be fair. There we go. Right. So let's put S9 equivalent on. Get that back on. So for S9, it's being very generous. Check RF gains up, it is. S9 for some reason needs just 10 millivolts. Sorry, 10 microvolts. The switches are okay and the sockets are okay. I've not been through all the potentiometers yet. Let's go over to the SINAD meter. That's in a reasonable position. This is stupidly good. Okay. Check we're actually in the right mode. Yeah, mini MF and not PD. Oh, this is another of those sets in 1,000. Squelch. So I've got the set on full squelch. Let's go over to the attenuator so you can see what I'm doing. I've got it on full squelch. Now there's no hard and fast rule on this, but I like them to be about 100 microvolts to open at full squelch. You don't want to squelch it never ever open. So 3, 10, 30, it's 100. It nearly came in at 30, but we'll put it down as 100 because basically that's what it is. So that's fine, but it might not be when we've done a retune. So we'll just do the opposite. Let's put the radio to standby. On its squelch, in other words. Put the signal generator back on, and the squelch is coming in at 0.42. So that's working very nicely. I'm going to switch it off, and I'm going to take the mic out just so nothing gets bashed against this immaculate radio. Making sure we have the right screwdriver. I got one of those stupid phone calls today. This is a message from your security at the bank. An Amazon purchase of £732 is about to be taken out of your account, and something else for something else is about to be taken out of your account. If this isn't for you, then you know what the scam is, and then, oh, well, let's have a look at your computer. Oh no, it'll be from India, won't it? It just doesn't worry me because there's only about £2 in the bank account. They'll have some chance getting that, won't they? Oh dear. And you do the number called thing, and you type it into Google, and it doesn't even exist. You know, I do have elderly acquaintances who get scared over that. My grandfather was an accountant on my mother's side, and in I think it was 1933, he fell for a scam which unfortunately originated from Ireland, and what it was, you invested in a rabbit farm, and it was all going to, of course, make you lots of money. So he invested £100. Now, you know, this is the time when, if you were lucky, you were earning £5 a week. So he invested an awful lot of money, and of course he lost a lot. And that's someone who was an accountant. Now that's interesting, isn't it? On this, you haven't got the sleeving. It doesn't matter, but you think, is that kind of early production? And they thought later, well, let's put sleeving on. So we'll do the serial number. Well, I was looking at the serial number to see if it was number 1, and it is 1121 2717. It actually nearly smells of new radio. So I can't see any nasty capacitors. I can't feel any nasty capacitors. I don't know about everybody else, but this part of my hand is very, very sensitive to heat change. So I can just put things like your upper lip is, which is ideal for seeing if your soldering iron's the right temperature. Of course, I can't remember the procedure to do the VCO, so we'll come back to that. We'll just run through the transmitter, and then I'll go for T. Okay, other glasses. So, why is this radio putting on my scary light on transmit? Let's do a retune and hope it goes away. Otherwise I'll have to get the spectrum analyzer on it. That's not the right tool. It's the 1.5mm one. I would go to the main meter. If I'd have had a cheap meter to hand, a cheap power meter, especially a Zetagi one, it would have been interesting to put this radio on it, because if my test set says there's massive spurious emissions, then I wonder what power this is doing into a normal power meter which isn't selective. There's food for thought. We are on the 30 watt scale, so we're going to detune this till we get an idea of where the peak is. To detune, find where it drops, retune, find where it drops, same again, detune, retune. As ever, this is important. I've got to set these temporarily to absolute maximum power and then quickly set it back to normal. Don't ever leave it in full whack. Legality aside, obviously we're going to do 4 watts. This is peak, peak and peak. If you leave it in full whack, it's not intended to do that. and the coils will melt over a period of time. And there's one down there, I'm prodding down there, you've got the 3 coloured ones, the one down there melts as well. So, and then it cracks the cores, and then they go open circuit, and so on and so forth. And the only way you're going to get new ones is out of another set. And that is something we're not encouraging, because these are jolly good. So we've got 4.8 watts on its absolute peak. It needs to be above 4.4. Sometimes you struggle to get 4.4. We might have to. I might pop the voltage up to instead of 30.8 volts. I might temporarily pop it up to 14 volts, just to try and get that 4.4, so we can do the tuning. And the tuning is clockwise on the yellow one till it reads 4.4 watts, which it now does. That stays exactly as you've got it at its peak from when you set it, and then the green one anti-clockwise. Service manual says 3.8 watts, but we're allowed 4, and so we're having 4. 3.8 so they can get it through customs. So that, I'm actually putting the tools away, I'm so confident. Right, channel 40, 4 watts, channel 1, 4 watts, absolutely spot on. Now, here's the thing, what's the current consumption? 4 watts, 4 watts, 4 watts, would come back to that. Now I would expect it to be something like 1.05. It's actually 1140, 1140. Which is about where, but that is high for that. I've seen these as high as about 1240. So it's all right, and we've no longer got. Let's go back to camera 6. So now when I key up, we're on the 30 watt scale. We're doing 4 watts. I've no longer got the spirit emissions warning light on. So there you go. I think that one was quite a way out, but it's just now right. So I don't, not suggesting this has been messed with, but you never know. We'll just get this one. This is deviation. We'll just get it to its central position. We've kind of got, this is the feedback thing. It's on the European model. It just has a fixed resistor here. I just don't know why they were doing this on the UK model. So I've got that to the central position. That's where my experience is that it works fine. So I'm going to plug into the test set behind, and if that's ready, we'll do the deviation. Go. Let's see what it says. Wow, it's 2.2 now. Of course, I've adjusted that, and that does make a difference. So we'll now adjust the other one as well. Wow. Okay. Measure that now on the Marconi test set. Go into deviation. Wallow. It's reading exactly the same. Wallow. 2.5p. So we never will know what that was. It said 1.5. That was reading right. Chances are it was 1.5. It's now 2.2 with a 2.5 peak. So that's kind of 1.3 to 1.5 if you're going to do a peak discussion. low power. Let's see whether we can sort that out. So low power, so many switches. Right. This might be new in the bag that these seem to suffer from drying up. I put it down to the chassis being open to the elements there and getting a little bit of probably corrosion, but it's 40 odd years old, isn't it? Well, there we have 400 milliwatts, and it smoothly went there. You know, it wasn't troublesome. That can stay on low power. So 400 milliwatts. Just do a start on receive. Just see where the signal generator. I'll start again. We'll just see where the test set thinks it is frequency wise. So it is still warming up. So it thinks we are doing 79092. So we want our receive to be 79092. So it is exactly the same. I'll do mate. So I'm going to start with the detector. Are we not plugged in? Have we disconnected our earth? I'll put it to there. Right, we're on to 100 microvolts on the test set, which is there. So we will look at the oscilloscope and make sure the detector. I think we'll use the RS yellow tool. There's the detector. Slightly out, which can mean that the sensitivity figures we've got were fake. I think we'll start with the front end today. And let's go over to our SINAD meter. The one there, hiding under the wiring. Is spot on. Spot on. Spot on. I'll do these a different way. I'll do these looking at the meter. So I'm looking at the front meter, the SINAD meter, and I'm looking at the oscilloscope at the same time. Next one. And the final one. Let's see if we've got a different SINAD reading. Well, it's just under the 0.2. But I'm between on this test set. We're between the bands kind of thing. I'll just see if we can get a different one for that. We actually are. It's still on that border, 0.2. It's probably 0.19, but we're just on that border. $20 dB. Yeah, it's 0.3. I could have said 0.295, but I'm not going to. So, you know, we've done it. It's going to... The detector was minutely out. But, yeah, it's absolutely exceptional. So we'll look at the meter. It's not far off... Excuse me, it's not far off correct. Because it was a bit... well, I've got it short now. I'm crocodile clips, I'm sure. Yep. Nothing new there, is there? It's come right. So that's the meter. It's jumping just where we want it to be. So again, that's a preset, which just wants a bit of switch cleaner. We'll give it a waggle around. You never know, this radio might have been stored where people smoked, because that really, really affects this kind of thing. There we go. Now let's do the squelch. Squelch to full. Let's show you the attenuator. So, the 100, it's exactly as it was, absolutely perfect. Let's check minimum squelch out. So I've got the signal generator on standby. When you do the IF, anything to do with the IF, like the detector and all this, this can really affect the squelch. So, we've actually come in at 0.3. It is coming in at 0.3, so that's got more sensitive. So 100 microvolts there, 0.3 microvolts there. The potentiometers are fine. Low power preset, cleaned. S meter preset, cleaned. So all we need to do when I come back in half an hour is do the frequency, and we'll just check the VCOs somewhere near where it should be. So I'm going to leave everything on so it can get nice and warm. Right, I'm back and we'll do the VCO. This is the more clear version from Mike M1 EMF. 4 volts, it's channel what? 40. When you're doing Cybernet 002F chassis, it's channel 1, just to confuse matters. So, what we're going to do. Transmit first, is it? Yeah. So on these it's transmit first. So we'll just pop that earth onto our test prod. You know, sometimes we come up against the Cybernet 134 which doesn't have this earth strap, and I fit it because it's so useful. So the far side of the test point is the far side of resistor 4, and it's supposed to be 4 volts on transmit. Let's put our test set into transmit. It's 3.03, which I'm going to have to adjust. Fast frequency, what a stupid fool is this one. It's nice and smooth as well, that. Oh, spot on the 4. And now we go to receive. Tiniest adjustment on that for receive. I mean, I don't need to, but that's the opposite way. They are interactive, so you do tend to need to recheck. So transmit is now 3.8. Here's the problem. I mean, I'm being daft being so exact on this, but there we go. That's receive, that's transmit, and we'll now do the frequency, which I decided to fiddle with anyway. See what the frequency counter's got to say. You never know, I may have made it better. Oh, I'm on channel 40, just change it to channel... there we go, channel 20. 79125. So I've twiddled it in the right direction, whichever that direction was. There we go. So we had 4 plus 3, it's now 4 plus 4, 27, 7, 9, 1, 2, 3. Test gear will still be warming up. We've set that. We never did set the power meter, did we, on transmit? Let's go back to that. So key up. That's low power. That's high power. It's over the 4, so we need to just drop that. It's also good practice to check the VCO on channel 1. So I'll just bring back the meter and we'll just go through that again. So now on channel 1, and we should have something like 1.7 volts. If it's stupidly 1.7 to 2.3, something like that. There we go, 2.19, and on transmit is 2.2. So that's within those kind of boundaries. Right, we are done with that now. That is finished. That is an exceptionally good set. And you know what? Consistently these are good. I've probably had more iffy York 863s, even though they're exceptionally well liked and competent sets. It's just that, you know, you don't get the bigger speaker on these like you do on the Barnetone 5-star. I mean, that's the other consistently good one, the Harvard 420M, consistently good. Right, we'll unplug the speaker. That's the internal one. We can switch off the test gear. We got rid of the warning light. needs an electric screwdriver when you can twiddle screws this quickly? He might have said to me, this is the one out of his glass showcase at home. Right, we'll plug in the roof aerial instead of the test equipment, and we'll see. It's just 6 o'clock. Ooh, look at that slight dent there. One and a Roger. Well, that's how Wish of CB always was. Absolutely nobody on. There you go. Well, thanks for watching. Oh, that wasn't FM. Thanks for watching the Harrier CBX Immaculate Radio from 1981 using the Cybernet 134 chassis.